What actually happens when you cross into a black hole? The physical reality of these objects is that once an object enters, it can never return to the outside universe. We generally view the cosmos as a predictable place. When stars reach the end of their lives, they usually follow a set path. They either fade away over trillions of years or explode in a sudden supernova. However, some massive stars take a different path. When their internal pressure fails, the entire mass of the star collapses inward, compressing into a single microscopic point. This collapse generates a gravitational pull so intense that even light, the fastest thing in existence, cannot achieve escape velocity. It creates a region of space where our standard mechanical models of motion stop working. This gravitational trap has a definitive edge called the event horizon. This boundary is the exact threshold where the inward pull of gravity exceeds the speed of light. Past this line, every possible path through space leads deeper into the center. This raises a practical question. What would actually happen to a human body if it were to cross this invisible line? The event horizon represents a shift in our understanding of space. It is the boundary where the mathematical laws we use to predict the behavior of matter and time no longer provide a map for what follows. As you first cross that threshold, your physical experience wouldn't change immediately. You are permanently trapped, yet you wouldn't feel the transition as it happens. The danger is the gravitational gradient. Gravity's pull is not uniform. Falling feet first, your feet feel a significantly stronger pull. Because gravity follows the inverse square law, this difference in force increases rapidly, accelerating your feet downward far faster than your upper body. Physicists refer to this uneven stretching as spaghettification. Your physical structure is lengthened and thinned. The gravitational forces overcome the molecular bonds holding your body together, drawing your matter out into a long, thin stream. In this environment, gravity acts as a structural force that dismantles any object that enters long before it reaches the absolute center. Eventually, the matter that composed you reaches the absolute center of the black hole's volume. This point is the singularity. All the star's mass is stored here in a region of zero volume and infinite density. At this coordinate, our mathematics fail. General relativity equations produce uninterpretable results, suggesting our understanding of mass and space is incomplete. Because our current physics cannot describe a point of infinite density, we do not have a scientific description for what exists inside the singularity. The singularity marks a boundary where the variables in our physical equations reach a limit that science cannot currently cross, leaving the center of the black hole as a gap in our knowledge of the universe. This journey looks very different depending on where you are standing. Imagine an outside observer watching you fall toward the horizon from a safe distance. Gravity doesn't just pull on matter, it warps time itself. From the outside perspective, as you get closer to the intense gravity of the black hole, your progress appears to slow down. To the observer, you will never actually cross the line. You will appear to move slower and slower until you seem frozen at the edge of the event horizon, gradually fading from view as your light stretches out. But from your perspective, inside the black hole, time continues normally. You feel yourself cross the horizon and accelerate toward the singularity in a matter of seconds. This creates a situation where two observers witness two different, mutually exclusive versions of history, one where you are frozen forever, and one where you have already reached the center. To explore more places where the laws of space and time challenge our observations, subscribe for more.